Volcanoes hold a special place in our consciousness. Stories of the destruction of the ancient Roman city of Pompeii continue to fascinate, while terrifying visions of explosive fire and molten rock play a key part in our nightmares. But less well known are the horrors of pyroclastic flows, avalanches of hot volcanic gases, ash and lava bombs, which can descend from steep volcanoes at blistering speeds of up to 700 kilometers per hour, vaporizing anything in their path. A volcanic eruption is one of the most dangerous and awe-inspiring natural disasters. When a volcano erupts, it spews out clouds of ash, lava, and even volcanic bombs. These are formed of molten rock that has been blasted into the air before hardening into solid lumps of more than 64 millimeters in diameter and falling back to Earth. The molten rock that emerges from a volcano is called lava. The liquid rock below the surface of the Earth is called magma. When lava flows, it usually moves quite slowly, but still poses a serious danger to property and human life. There are 4 different types of volcano. The simplest kind of volcano is called the scoria cone, also known as the cinder volcano. They can appear very suddenly when gases propel lava high into the air, where it breaks apart into small fragments or cinders. As they drop, the particles cool and fall around the single vent to form conical hills. Over time, the sides of a cinder cone volcano can become very steep, but they rarely grow larger than about 300 meters tall. Many cinder volcanoes are monogenetic, meaning they will only erupt once before becoming dormant. Famous examples of the cinder cone volcano are Sunset Crater in Arizona, a volcano that is 305 meters high, which first erupted around 1065. And Paracutin, one of the youngest volcanoes on Earth, which appeared suddenly out of a cornfield in west-central Mexico in 1943. The second type of volcano is called the stratovolcano, also known as the composite volcano.
So there are very different shapes of volcanoes, and that's because of the different ways in which they erupt, and they build up material differently. So a stratovolcano is the one that we associate with the most explosive types of eruption. And they're capable of a very wide range of behavior, but they build up those classic cone shapes that we might associate with something like Mount Fuji or Mount St. Helens.
These are the most violent and dangerous kind of volcanoes. They can be massive, sometimes reaching heights of up to 3 kilometers. The slopes of the composite volcano tend to rise slowly at first and then become very steep with a narrow vent at the top. They have a system of conduits that channel the molten magma from deep within the Earth to the surface. Because they can deliver so much magma to the surface, they can grow thousands of meters tall. The stratovolcano can explode with extreme violence and then go dormant for tens or even hundreds of years before coming back to life again. A famous example is Mount St. Helens in the Pacific Northwest region of the United States. This stratovolcano last erupted in 1980, killing 57 people in what was the deadliest eruption in American history.
Before Mount St. Helens, it was a reasonable assumption to make that the big eruptions from volcanoes come out the top. But Mount St. Helens taught us that sometimes that's not the case. It blew a giant hole out the side. We're still analysing data from Mount St. Helens because it's still valuable to science and there's so much more to learn. What's special about Mount St. Helens is that we've seen the beginning, during and after effects of the eruption. which means that we can piece together warning signals and the effects of the eruption itself. Because it's fairly well studied, we have a mass of data and understanding and knowledge to then ask advanced questions upon. And it's these advanced questions with the context of what we do know about Mount St. Helens that allows us to make more progress elsewhere.
The third type of volcano is the shield volcano. These are broad, dome-like structures, and when viewed from the air, look like shields, hence the name. Mauna Loa and Kilauea in Hawaii are both examples of shield volcanoes. The largest volcano known to humanity is a shield volcano, estimated to be the size of the entire Hawaiian island chain. Fortunately for us, it is not on this planet. It is a dormant shield volcano found on Mars called Olympus Mons. Its peak is more than twice the height of Mount Everest, making it the tallest mountain in the entire solar system. The final type of volcano is called the lava dome.
A lava dome is when you have a type of magma that comes out as lava that's very, very slow and stiff. And so instead of flowing away from the volcano top, it piles up at the top of the volcano and creates these big features that are as tall as they are wide. To a sort of untrained observer, going up to a lava dome might be slightly disappointing because it can look a little bit like a giant grey mass of rubble. But when you fly over it, you can see cracks into the interior. So only a few tens of centimetres down, it's glowing red, and you can see steam coming off it. And when they collapse, they generate these things called pyroclastic flows. So they feel powerful, lava domes. So it's a pretty intense experience going that close to one. And the thing about lava dome eruptions is that they can suddenly change their behaviour. So if you're quite close to them, there's always this sense of approaching menace, and we have to be really careful about how we approach them and make sure that the people who are further away and monitoring the volcano are in contact with us.
A good example of a lava dome volcano is Mount Pelée, an active volcano on the Caribbean island of Martinique. Its last major eruption was in 1902, when it destroyed the port of Saint-Pierre and killed 30,000 people, some 15% of the island's population. There are over 500 volcanoes in the world that have erupted at least once. 50 of them are in North America. An index was devised in 1982 to measure the force of an eruption so that different events could be compared. Called the Volcanic Explosivity Index, or VEI, it is determined using a range of factors, including the amount of material vented from the volcano, the height of the eruption cloud, and how long the eruption lasts. This is expressed on a scale of 0 to 8, with each number representing a 10-fold increase in the explosive power of the eruption. One of the most terrifying and deadly phases of an eruption is undoubtedly the pyroclastic flow. Sometimes referred to as a glowing avalanche, the pyroclastic flow is formed of many different components. There are rock fragments following the volcanic explosion, particles of lava and magma that are mixed with air, water and gas from the eruption, as well as water vapor from melted snow and ice. This extremely hot fluidized mixture can reach temperatures of 1,000 degrees Celsius and surge down the slopes of the volcano at astonishing speeds of up to 200 meters per second. A pyroclastic flow will instantly incinerate anything in its path. And when you consider the heat of the flow, its speed and its reach, it is one of Mother Nature's most terrifying and deadly forces. Another deadly event resulting from volcanic eruptions is the ash landslide, called a lahar. Lahars are a hot or cold combination of volcanic debris and water, which advance down the slopes of a volcano, often moving down a river valley. They tend to occur on or near stratovolcanoes. While its initial flow may be quite small, a lahar can quickly grow in volume as it sweeps up soil, trees and rocks, even bridges and buildings. Lahars can easily grow to more than 10 times their initial size as they roar downhill. In steep areas, lahars can travel faster than 200 kilometers per hour. Pyroclastic flows can trigger lahars when super-hot rock debris melts snow and ice as it rushes down the volcano's flanks. Torrential rain during or after an eruption can mix with the fine particles of ash and other debris on the volcano's slopes and quickly turn into a dangerous and fast-moving lahar. Rain can cause lahars a long time after an eruption, especially if vegetation has not managed to consolidate the deposits on the slopes of the volcano. There are many volcanoes in the world that have not erupted in years, while others are in a very active phase, perhaps not erupting violently, but with smoke, steam, ash and lava constantly venting.
It's the simplicity of the characterization of extinct, dormant, and active that holds value, because they have different issues with each state. If you have an active volcano in your back garden, you need to pay attention to it all the time. If you have a dormant volcano in your back garden, maybe you should be keeping it in mind, but it might not change the day-to-day activities that you have. If you have an extinct volcano in your back garden, then you're pretty happy that it's not going to erupt, and if an eruption happens, it won't be from that point. But as we learn more about volcanoes, particularly as we apply new technology, more sensitive technology, more sophisticated technology, the line between dormant and active is becoming a little blurred. And that's because the new technology can hear things that we couldn't before. So if we deploy this technology and we get signals from a dormant volcano, is it waking up or was it never truly asleep? According to the definition of extinct, it means no activity in the last 10,000 years. Now, 10,000 years is a long time even for a volcano. Normally, they erupt more frequently than that. So if you go to the volcano and measure the age of the youngest rock, and that's more than 10,000 years, then it's declared extinct.
When experts assess which volcanoes are the most dangerous in the world, they take several things into consideration. How many people live nearby, the types of magma that emerge during eruptions, and each volcano's eruption history. A volcano that has laid dormant for a long time can pose a higher risk because of the mounting pressure inside it. Taking all this into account means that Mount Vesuvius, a stratovolcano located just 14 kilometers away from Napoli, is also one of the most dangerous. While experts disagree on the precise number of incidents, it is clear that Vesuvius has erupted at least 30 times since its iconic eruption in 79 AD. The last eruption occurred in 1944, when 26 people were killed.
For the Romans, there wouldn't really have been a living memory of it as an erupting volcano. But in Italy, there are other volcanoes that erupt pretty frequently. So probably they knew it wasn't entirely benign. And in the run-up to the eruption, we do know there were known signals that things weren't quite right down below. And there was a big earthquake. And then we think there were sequences of these smaller little earthquakes as that magma's trying to make its way up towards the surface in the run-up to the eruption. And the Romans would have felt those, and they would have been fairly intense, I would imagine, in the few days leading up to the eruption itself.
There are plans in place to evacuate 600,000 people should Vesuvius show signs of erupting again. Active volcanoes in densely populated areas obviously pose the biggest threat to life.
In other places around the world, there are volcanoes that erupt very frequently. So the big contrast from Vesuvius is Stromboli, which the Romans called the lighthouse of the Mediterranean, and that's a little island that had a little eruption that happens every 10, 15 minutes. It erupts extremely regularly. And so the populations who live with those sorts of volcanoes tend to live with it in a different way.
Volcano de Fuego, a stratovolcano situated less than 44 kilometers from Guatemala City, the capital of Guatemala in Central America. has erupted 600 times since 1542, including the last explosive eruption in 2012 that forced 11,000 people to flee the area, but luckily did not result in any loss of life. For many people living in the shadow of the volcano, it was an uncomfortable reminder of the awesome power of the Volcán de Fuego, sitting right at their doorstep. But when the volcano suddenly exploded just before midday on the 3rd of June 2018, many of them had no time to evacuate. It spewed a cloud of ash and lava 10 kilometers into the air. The explosion caused the rocky surface of the volcano to shatter into dust. It mixed with ash and superheated gas into a pyroclastic cloud of death that engulfed the villages of San Miguel Les Lotes and El Rodeo, instantly killing more than 100 people. The 3,700-meter-high volcano continued to erupt for more than 16 hours. After the initial explosion, a stream of lava spewed down the side of the mountain. Guatemala's coast was also hit by an earthquake, though there were no reports of damage. Hundreds of emergency and military personnel faced appalling conditions to retrieve bodies from the lava.
Habían varias personas que se encontraban observando la erupción. Al momento pues, de bajar esta lava pues, provocó que varias personas quedaran atrapadas. Como resultado hay 8 personas fallecidas, son 5 personas adultas y 3 niños.
The ash and lava was still so hot that the soles of some firefighters' boots were melted away. The firefighters were unable to reach people they knew were trapped in villages on the slopes of the volcano because roads leading to the area were cut off by pyroclastic flows. It suddenly dawned on them that the volcano's activity had started to increase again after the initial blast. Gas, mud, and ash flowed down the slopes of the volcano. As stones hailed down on them, darkness fell as the sun became obscured by more ash clouds spewing into the air. Emergency personnel were forced to retreat from the villages until early the next morning. Guatemalan President Jimmy Morales declared a state of emergency and ordered the population to heed warnings from emergency officials. He also declared 3 days of national mourning.
La comunidad completa pues está dolida, lastimada porque aparte de todo lo material que perdieron, pues lo más principal fue lo humano.
Mi familia, mi papá, mi mamá, mis cuñadas que ahorita están enterradas. Faltan 10 familiares de nosotros que todavía no aparecen y esperando todavía en Dios que aparezcan, ¿va?
Rescuers that reached the town of El Rodeo reported that it had been buried in heavy ash, which could have reached temperatures of up to 700 degrees Celsius. They poked metal rods into the ground, releasing clouds of smoke into the air, showing that temperatures below the surface were still extremely hot. 2 days after the initial explosion, volcanologists reported that the eruption seemed to have ended for the moment. Soldiers and firefighters continued searching for those missing, but the death toll had climbed to 69. By now, the ash from the eruption was covering a radius of 19 kilometers around the volcano. Satellite footage of Fuego revealed that the massive dark gray cloud from the eruption was visible from space. By Wednesday, the death toll had climbed to 75 people and a further 200 were still missing. Officials were worried that a downpour of additional rock and debris could destabilize the slopes, sending lethal lahar flows of water mixed with volcanic ash and debris hurtling down the volcano. They called everyone off the mountain, halting the recovery effort for a whole day. Some relatives of the missing defied police roadblocks and went to their families' houses.
Venía la gran correntada de lava allá arriba. Entonces, lo único que nos dio tiempo fue salir huyendo con nuestra familia y lo demás aquí se quedó y saliendo de la duda yo vine a ver cómo estaba aquí nuestra casa, ¿va?
They tried to dig through the rapidly hardening ash, which they feared had buried their relatives, using whatever tools they could get their hands on. There were concerns that the government's focus seemed to be on getting the highway cleared and not recovering the bodies of the dead.
Nosotros lo que queremos es rescatar nuestros cadáveres de nuestros familiares. Yo tengo 50 familiares sepultados. Ya que el gobierno nos abandonó, nos dejó como basura, pues nosotros, por nuestra propia cuenta, vamos a desenterrar nuestros cuerpos.
By the time the authorities could get heavy digging machinery to the buried towns, it became clear how little chance of survival there had been for anyone trapped in the path of the pyroclastic flows. Amid scenes of apocalyptic devastation, the death toll reached 112, with 197 still missing. Many people didn't accept the government's official death toll. They were convinced that the scale of fatalities were being underreported. It emerged that scientists at the National Institute of Seismology, Volcanology, Meteorology, and Hydrology had warned officials in the early morning on the day of the eruption. But despite these warnings, the National Coordinator for Disaster Reduction did not issue a red alert and evacuate communities. Even though nearly 200 people died there, the area around the volcano will continue to be inhabited. The deaths in the Fuego eruption were mainly attributed to the lightning-quick pyroclastic flows typical of the stratovolcano. And although it brought death and destruction to a wide area, Fuego's reach was not nearly as far as an event that occurred in April 2010, when a volcano in Iceland suddenly erupted, spewing a vast plume of ash that spread across much of Europe. The eruption of Eyjafjallajökull became an international event as around 20 countries closed their airspace and forced flight cancellations that affected 10 million travelers, as well as thousands of businesses that relied on air freight. The volcano Eyjafjallajökull had been dormant for nearly 200 years when it burst into life in March. Although relatively small, at a rating of 1 on the Volcanic Explosivity Index, it was a mere suggestion of the violent activity that was to come. On the 14th of April 2010, earth tremors were reported under the summit of the Eyjafjallajökull glacier in the south of Iceland.
In the lead up to the eruption, one of the things that you're going to be most aware of is that space problem the magma's creating. So it will generate lots of earthquakes and shaking, there's maybe bulging. But that kind of slow run, the slow timescale of volcanoes erupting becomes really fast once the volcano starts to erupt. So if it's an explosion, there will be a sudden change, and you will start to see a huge pulse of gas, ash, and bits of solid magma flying out of that volcano. And there's been slow motion footage taken that's shown that there's even a sound wave that comes out ahead of this, because this happens so quickly.
The force of the volcanic eruption under the Eyjafjallajökull glacier sent a plume of ash 8.5 kilometers into the air. Heavy ash fell over the areas to the south, with police reporting that visibility had been severely reduced, in some places down to zero. Icelandic air traffic control received 2 reports from commercial aircraft of steam plumes rising from the glacier. But because the glacier remained covered in cloud, it was impossible to see the extent of the volcanic activity occurring on the ground. But there were alarming clues about the severity of the eruption. The water level in 2 nearby rivers had suddenly risen by over half a meter, showing that there had been substantial melting of the volcano's glacier. Concern grew about the ash plume, which by now was engulfing much of northern Europe. It contained large amounts of microscopic abrasive particles of silicates or glass fibers, capable of clogging jet engine. Once ingested, the particles can melt, causing the engine to flame out and stall. Because of the danger of catastrophic failure of any aircraft flying into the ash, and to ensure the safety of passengers, aircraft were left idle on the tarmac of some of Europe's busiest airports. Practically all flights over mid, north and eastern Europe were cancelled until further notice.
It's really a bit strange to think that a volcano would affect the flights, but yeah, so it's not something you expect to happen.
Other flights were either rerouted north over Greenland or south over Spain to avoid the cloud, which now stretched 1,930 kilometers from Iceland to northern Spain. The plume of ash was further carried along by Atlantic winds and later forced the closure of 15 airports in northern Spain and was expected to expand into parts of France. More than 100 flights were cancelled at Portugal's 3 international airports. It was the most serious disruption of European air traffic since the Second World War. As the eruption continued, meltwater from the summit of Vatnajökull, one of the largest glaciers in Europe, increased dramatically. It was estimated that the volcano was ejecting about 750 tons of magma every second, much of it through a fissure that was already 2 kilometers long. Tuesday, the 20th of April, most of the ice in the crater appeared to have melted. But it was another month until the eruption had subsided to the point that no further lava or ash was being produced. Finally, in October 2010, scientists monitoring the volcano declared that the eruption had officially ended, although the area was still geothermally active and might erupt again.
The explosive activity might drop down for a period of time, but then we will have, over maybe an extensive period of time, months to even years, intermittent explosive eruptions.
Taking stock of the devastation caused by the eruption, experts estimated that at least 55 million cubic meters of ice melted during the eruption.
It's a scientist's job to report the facts and explain what would happen if there were an eruption, and then recommend a course of action that will provide more information to decision makers. Now, governments will invest more in monitoring and volcanology in general because the risk to society is growing. Our world is more interconnected now. Look at what happened in Eyjafjallajökull. If that happened 200 years ago, it wouldn't have had nearly the same impact as it did on the world economy, through airlines, etc. So now disruption, indirect disruption from volcanoes has a large impact. And that just underscores that we need to urgently understand what happens before a volcano erupts, and so we can put in place plans to mitigate against those hazards.
Every volcanic eruption is different. Eyjafjallajökull caused mayhem because of its ash cloud and fuego with its terrifying pyroclastic flows. But when Kilauea, a shield volcano on the island of Hawaii, erupted in May 2018, it demonstrated a very different kind of behavior. Kilauea is the youngest volcano on the island of Hawaii and looks like a bulge on the side of Mauna Loa, a much bigger volcano. It rises 1,227 meters above sea level and makes up about 14% of the land area of the Big Island. Legend supposes that the lava lake at its summit is home to Pele, the Hawaiian goddess of volcanoes, indicating the significance of Kilauea to the people of Hawaii.
Provides us a window of a deeper level than usual because it hasn't been modified on its way to the surface. The fact that it's coming up so rapidly means that it's preserving the information that it carries from depth.
Although it had been erupting continually since 1983, the people on Big Island had learned to live with the volcano. In fact, it was seen in a very positive light, attracting tourists eager to see such a dangerous force of nature close up.
Obviously, the geothermal energy around volcanoes is a wonderful benefit that they bring with an infinite supply of power and hot water. But also, for many populations, these geothermal areas are fantastic tourist attractions.
In places, people could get so close to the lava that it became a tradition to take postcards and burn one corner in the flow before sending them off. But all that changed when a magnitude 5 earthquake struck the Big Island and triggered a violent and dramatic eruption, turning the tourist volcano into a dangerous threat to life and property. The day before, on Wednesday, the 2nd of May, seismologists had noticed significant volcanic activity coming from Kilauea. As the volcano blasted solid and molten rock fragments and gases into the air, the authorities immediately told residents in the surrounding area to make preparations to leave.
So at 1:30, after we all kind of got up and said, okay, well, I opened the door to see if I could see anything. And of course I could see an orange glow coming through the forest. And I said, wow. And I heard crackling, and we're all kind of just going, whoa. I said, well, we're not leaving until we hear the siren. And the moment I finished the sentence, the siren went, whoop. We all looked at each other and said, yep, everybody in the car. And out we went.
When the volcano started to spew lava into residential subdivisions in the Puna district of the Big Island, compulsory evacuation orders were released. The volcano became increasingly active. There were quakes, with hundreds of tremors of magnitude 2.5 or higher. But shortly after midday, a quake measuring 6.9 knocked out power to thousands of islanders, causing sea level fluctuations which terrified residents, fearful that it would generate a tsunami. Fortunately, the sea remained relatively calm, but lava flowed down the sides of the volcano and gases spewed into the air. Homes were destroyed as eruptions increased.
During the 2018 eruption, the magma moved and created pressure that then resulted in the opening of new vents for that magma to pour out of during the course of its eruption, sometimes right in the middle of a road. On a volcano like that in the Big Island in Hawaii, there's an almost continuous supply of magma coming into the base. But it's one of the best monitored volcanoes in the world, if not the best monitored volcano in the world. And what they picked up was signs that new magma was coming into the system, causing pressurization and causing the ground to move up.
As news of the eruption and dramatic footage showing houses being engulfed by red-hot flows of molten lava was beamed around the world, people began to wonder why anyone would choose to live near an active volcano.
Volcanoes and their immediate environment offer a lot of benefits to people who live around them. So they create soil that can be more fertile than surrounding area. There's a lot of volcanoes in the tropics, and they are a little bit of higher land that's a little bit more pleasant to live in. They provide geothermal energy and soil and rock resources as well. And when you think about how often volcanoes erupt, it's in the grand scheme of things, it's not very often. So I think often people live around volcanoes because it's worth enjoying all of those benefits for the small but finite risk that it's going to erupt during their lifetime. One of the things that's very challenging about volcanic eruptions is that they aren't just instantaneous. A volcano can be in eruption for many days and weeks and months. And so sometimes what we're doing is we're asking people to move away permanently or for very long periods of time. And that's a difficult thing to do. People are attached to where they live, but also in many volcanoes around the world, people are dependent on that area for their livelihoods. Once a volcano's erupted, it obviously creates a lot of damage, and people may want to build quite close to where that damage was created. And I think one of the things that we are doing now as volcanologists is we're recognizing we have to work in partnership with the communities who are impacted to try and work out the best way to choose the place that's going to be the safest to build back and try to ensure that they're ready as much as they can be for future eruptions.
A week after the first new eruption, 12 more fissures opened up in Leilani Estates on Hawaii's Big Island. The new points of lava flow showed that the eruption of Kilauea was ongoing. There were now major disruptions to life on the island, with more evacuations needed.
It ain't done yet, it's still going. We don't know when it's going to be done. They're talking about it's got enough strength and energy to last for weeks, if not months.
On Wednesday, the 9th of May, Kilauea volcano erupted again as 2 new vents released toxic gases into the atmosphere. The Civil Defense Agency ordered the immediate evacuation of residents from Lani Puna Gardens on the east side of the Big Island. Scientists noticed a drop in the lava lake at the summit of the volcano. They warned that this might create conditions for an explosion that could send ash and refrigerator-sized boulders shooting into the air. The following day, the authorities warned that mass evacuations might be required. Levels of sulfur dioxide reached dangerous levels, which could prove fatal if inhaled, and residents were at risk from magma bursting out of the ground.
People who are frail or who have underlying COPD, that's chronic lung disease, we worry about them quite a lot. That can be made much worse by spikes in sulfur dioxide. So checking people's lungs, making sure they have their medications, making sure we evacuate them further away if they're bad.
By the following weekend, there were now 17 open fissures since the lava flows began on the 3rd of May. On Wednesday, the 16th of May, following the rise of an ash plume several thousand meters into the air, the Hawaiian Volcano Observatory issued a code red, warning residents that additional activity could be expected. They cautioned that at any time, activity could become more explosive, producing ballistic projectiles near the vents. The following day, another 2,000 people were forced to abandon their homes. Several schools closed because of the risk from high levels of sulfur dioxide.
I have already evacuated everything. I just came down to say goodbye to my neighborhood one last time.
There were also earthquakes around the volcano which damaged many roads, including Highway 11, near the entrance of the Hawaii Volcanoes National Park. Fast-moving lava spewed into a region southwest of Leilani Estates, cutting off about 40 homes in a remote region. Hawaii's County Civil Defense warned that brush fires caused by the burning lava were threatening homes in the Malamar Key Forest Reserve. Residents were immediately evacuated. Then scientists noted something worrying. The lava spattering out of fissures in Lower Puna seemed to be different. It was coming out faster and more dramatically. That contrasted with the first 2 weeks of the eruption, when activity was largely a slow oozing of a very thick, pasty lava that wasn't moving very far. Scientists explained that the lava of the first 2 weeks was probably from magma stored underground, making its way onto the surface as a result of the fresh magma pressing down from Kilauea's summit. The lava now coming out of the latest fissures was different. Scientists braved noxious fumes and spattering lava to gather samples that would be crucial for research.
One of the most important things for volcanologists in these sorts of situations is really teamwork. So it's making sure that there's people who have their eyes on the instruments and that you are not doing anything that is too risky and that you think about it very carefully in advance. And so when something like that happens, what you're really thinking is, this is quite scary, but you have to have strong trust and reliance in the team that are around you so that you're going to get out in time.
A chemical analysis of the samples showed that the fresh, more violent magma had come down from the summit of Pu'u'o'o, a volcanic cone situated in the eastern rift zone of Kilauea. This was fresher and hotter magma, with the potential to produce lava flows that moved with greater ease and therefore covered a wider area. A wall of lava blocked part of a coastal road, cutting off a key escape route for residents and hampering evacuations. Fresh lava flows overwhelmed more houses, while the ash plume continued to ground flights in the area. The situation for residents on Big Island was steadily worsening. Lava flows forced the shutdown of a geothermal energy plant that normally provides about a quarter of the island's electricity. By now, the lava had reached Big Island's south coast. As the lava plunged into the ocean, it caused some of the 1,000 degrees Celsius molten rock to explode into lava bombs that shot hundreds of meters into the air. The lava also reacted with the salt water to produce poisonous gases and triggered further safety warnings. When the lava flows reached the Pacific, it created thick, hazardous clouds known as lays, which is a kind of hot and corrosive gas mixture. The clouds contain hydrochloric acid and glass particles, which can cause irritation and breathing difficulties. Even the wispy edges of the clouds can be enough to cause irritation. Residents were told to stay away from any ocean plume since they traveled on wind that was liable to change direction without warning.
But they need to really pay attention to what's happening, because anything can happen. Mother Nature, Madame Pele, can come out at any time. But we don't want to cause panic. We want them to just be well informed.
So volcanology is a very exciting and dynamic science because volcanoes throw all sorts of challenges at us. They're capable of erupting in all sorts of different ways, and they can change how they erupt during the course of even one eruption. And also what they can do is erupt for long times. And that's what we're trying to face, the challenge of figuring out how to forecast that and forecast those changes during the course of an eruption. And all of these mean that there's all sorts of new understanding and techniques that improve how we do that all the time.
The lava flow continued unabated. A huge river of molten rock crept several kilometers across the landscape towards the eastern tip of the island. It swallowed 2 entire seaside housing estates. It took just a matter of days for a relentless wave of lava, over 4 meters high and 800 meters across, to bury hundreds of homes. It even vaporized the island's largest freshwater lake. Within 4 hours, the 400-year-old Green Lake, which was about 60 meters deep and had been a popular swimming spot, completely disappeared under a mass of molten rock. In mid-July, a tiny island, less than 10 meters wide, suddenly appeared off the coast of Big Island. It wasn't long before lava filled in the gap between the new island and the shore, and it became part of the changing coastline caused by Kilauea's eruption. It was a reminder of how the Hawaiian island chain was first formed.
The Big Island of Hawaii is around 1 million years old, but it's part of a chain of volcanoes, and the oldest chain of those that stretch across the Pacific is about 80 million years old. And that observation that the volcanoes seem to get older as you go west across the Pacific is part of the evidence to say that there's a hotspot in the mantle underneath that is more or less fixed, but as the tectonic plate moves across like a conveyor belt, the volcanoes that are produced start traveling off towards the west, melt within the earth, travels upwards until such time that it hits the surface. Now that could be the surface of a continent, or in the case of Hawaii, it's the bottom of the seafloor, and it starts a small volcano. And over time, it builds up and builds up. And if it builds up fast enough, it will reach the top of the sea.
Throughout the eruption, a remarkable transformation had occurred to the lava lake crater at the top of Kilauea. The Hale Ma'uma'u crater at the summit had been rumbling non-stop since the eruption began in early May. Then the lava lake began to drain quite suddenly as the reservoir of magma beneath it began dumping its contents out of fissures on the volcano's slopes. The United States Geological Survey sent a drone into the crater to see the dramatic changes. It showed that the steep walls of the crater were collapsing inwards, with large chunks of the rim, including a parking lot, which served the Hawaii Volcanoes National Park, swallowed by the crater's collapse. The powerful activity was triggered by the flow of magma away from the summit crater eastwards towards the rift zone. As the crater got deeper, the walls began to collapse inwards, which led to further explosive releases of gas, ash, and other volcanic debris.
The lava lake in the Hale Ma'uma'u crater in the volcano of Kilauea started draining from the inside. And as each phase of the draining happened, the eruption site flared up. And this is part of the evidence to link the two phenomena. and suggests that this is a linked plumbing system in the lower eastern rift zone of Hawaii. The magma is interconnected, and as each cycle of the volcano of Kilauea occurs, it's becoming more and more evident that the behavior of the lava lake can be used to understand the eruption site itself.
On the 9th of August, the lava flow finally stopped expanding. And with the lull in activity on Kilauea continuing, volcanologists are saying that the eruptive period, which first began in 1983 and continued right through to the recent and most violent cycle, is over.
So one of the things that was amazing about the eruption that happened in 2018 is that it was exceptional. There were huge amounts of material, we opened up new vents, and that caused a shift in the magma system. So before that, it was erupting continuously for decades. It's quite likely now that it may remain quiet for a few years. That's what happened the last time it had one of these really big eruptions. But what's for sure is there's still magma underneath the ground there, and that the shift will probably cause it to erupt again, and probably in the lifetime of the people who live on the island.
If and when eruptive activity does eventually return, it will be classified as an entirely new eruption. A period of constant eruption of Kilauea lasting over 35 years will have come to an end.
The simple answer is we don't know exactly what will happen to the lava lake. Will it refill? Will it be a hole in the earth for times to come? But what we do know about Kilauea is that it has gone through cycles of repeated lava lake formation and draining. So one reasonable idea about what might happen is that the lava lake will refill and an eruption will happen as it drains. Volcanology is a fairly new science in that there's lots of different sciences that are trying to understand the same phenomena. You can approach it from a chemical point of view, you can approach it from an atmospheric point of view, you can approach it from a geophysical point of view. And it's as these fields emerging and is called volcanology, that's only happened in recent decades as a modern science of volcanology.
One thing we do know is that volcanoes will continue to cause death and destruction for as long as there is life on Earth. And whether it's the horrors of pyroclastic flows, the choking gas, or the molten lava, volcanoes are truly one of Mother Nature's most combustible killers.